Alrighty, so this video is about Lewis dot structures. I know I have a beautiful periodic table drawn here, but that is not what this video has to do with. I'm just using this because I don't have any of my periodic tables with me, so this is important for the Lewis dot structures. First thing you have to know with Lewis dot structures is how many valence electrons each compound has, or each element has. So if we're just lazy, we have hydrogen's group right here. He has 1. Those are also your alkali metals. The alkali metals only have 1. The alkaline earth metals have 2 valence electrons. Then you have aluminum's group has 3, carbon's group has 4, nitrogen's group has 5, oxygen's group has 6, the halogens have 7, and the noble gases have 8. The noble gases are the only ones that do not require anything to happen with their Lewis dot structures in order to gain their octet. They already have their octet. So that's why these guys, they don't react to anybody. They're stubborn, they're prideful, they don't like talking to anybody. So they will not form any bonds, they won't do any reactions because they already have their octets. Alkalis to the halogens, however, they don't. Of course, these are your transitional metals, and like always, we ignore them because with Lewis dot structures, they are a pain in the neck. So we're going to pretend like they don't exist because we'll have other things to deal with them. I'm going to pause this, I'm going to erase this, and come back. So I'm back. You wouldn't even have known I was gone. It just all of a sudden would have vanished. So now let's look at this. Let's follow the rules for drawing out Lewis dot structures. So I'll have an oxygen, a nitrogen, and a carbon. The rules are the same rules that we did when we were doing those arrows and we're doing electron configuration. We had to fill 1 on each line before we put the opposite spin. That rule still applies to the Lewis dot structures. So carbon, we know, has 4 valence electrons. So what you do is you start at the top. 1, 2, 3, 4. All 4 sides have 1 valence electron. We have accounted for all 4 valence electrons, meaning that is carbon's Lewis dot structure. Nitrogen, on the other hand, has 5. Do the same pattern. 1, 2, 3, 4, 5. And we're done. It does not matter where this 5th one is. It could have been there, it could have been here, could have been down here, could have been over here. It does not matter. As long as only one of them has 2. Oxygen, we've gone up the chart. Now we have 6 valence electrons. So 1, 2, 3, 4, 5, 6. Ta-da! We're done. Because I'm psychotic and I prefer it this way, I always put the second one down here. But again, does not matter where that second one is. It would have been right as long as 2 of them have 2 and 2 of them have 1. This could not have been drawn. Oxygen, 1, 2, 3, 4, 5, 6. Yes, that's still 6 electrons. However, that breaks all sorts of rules because you had to have 1 here before you could have 2 on another one. So, not even possible. Pretend like it doesn't even exist. The smaller atoms, like lithium or magnesium. Magnesium has 2. 1, 2. Ta-da! Lithium has 1. 1. Yeah, lithium might have more than 1. I can't remember that one off the top of my head. So, that's that. The other part of Lewis dot structures is trying to actually connect them to each other. So when we're drawing out those covalent bonds. So let's say we have like NH3. The first thing you have to do is you have to count how many valence electrons each of these has. So nitrogen, we know, has 5 valence electrons. Hydrogen has 1. However, we have 3 hydrogens, so we have 3 sets of 1, which gives us 8 valence electrons total. So, now going through these steps of drawing these Lewis dot structures. Step 1, figure out the central atom. The least electronegative goes in the middle. Hydrogen can't be in the middle, halogens can't be in the middle, typically. Now, we put the other elements around it. So H, H, H. Beautiful. Step 2, connect them. One line, one line, one line. Okay, subtract the 6 for that. So now we have 2 valence electrons left still. Oops, sorry. So now we got to figure out where to put these last 2 valence electrons. Well, hydrogen only wants 2, so this one's already got 2, so he's happy. That one's already got 2, he's happy. That one's already got 2, he's happy. So those last 2 go right here, and that completes the octet. Third rule, make sure you have all your octets. 2, 4, 6, 8. We already counted the hydrogens. Everybody's happy. We've only used 8 valence electrons, so we are good. Now let's do a polyatomic instead. Those are a little bit more crazy. So we'll use sulfate. Why sulfate? Because it's the one that popped in my head first. So same as before. Sulfur has 6 valence electrons. Oxygen has 6. There's 4 of them. 6, 6, 6, 6, and 6. 6. How many 6 did I say? I don't know. 6, 12, 18, 24, 30. So we have 30 valence electrons right now. Then we have to look up here. Sulfur has that -2 charge, which means that we add 2 more valence electrons, which now puts us at 32 valence electrons. So now we look for the least electronegative. Sulfur is the least electronegative. So we'll put sulfur in the middle. And then we have the 4 oxygens. 1, 2, 3, 4. 1, 2, 3, 4. Subtract the 8 from that, and that drops us down to 24 electrons left. So you just start putting them around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. You look at everybody. Oxygen has all 8, 8, 8, 8, and sulfur has all 8 being shared. So there we go. We are all good with that Lewis dot structure. Sorry that this video is a little bit longer, but hopefully that does make sense.